invite them to sign in.
And Vision Committee.
Okay, hello. We're starting the meeting now. We solved the problem. So today we're going to be talking about or going through a programming competition type problem and like solving it together as a team, but also not so much together because that would get really complicated. A whole bunch of people working on the same problem, keeping it on the same idea.
Do a CSC 150 style.
All right, so first of all, for attendance, go to dsuprog.club and then open up the meeting. And there's also questions there. Well, not questions, a place to put questions. And I've got a link to the problem that we're going to be solving. And also, if you are going to be going to DigiKey, check your email and make sure you got an email from them. And if you're not going to be going to DigiKey and you did get an email, that's also a situation. But if everyone's found the problem here, it's called sort, which is misleading because you don't just sort things. So basically what we've got here is a story about someone named Mirko that I don't want to read all of, so I'm instead going to skip all that and just go to input and output and then explain what this says more simply. They're going to give us two numbers in one line, the first one being how many numbers is in the second line of numbers. And as you can see here, that number will be between 1 and 1,000. And then the second number in the first line, that's going to be wait, which number is that? Oh yeah, that's going to be the maximum number that gets used in the list of numbers. The second line is the list of numbers that I was talking about before. It's going to be this first number, many numbers long, and the maximum value in that list is going to be this second number. So then, if you read through this, you can see you've got n numbers smaller than or equal to c. Basically, we're sorting these numbers based on how often they appear. So if you look down here, you've got a bunch of 2s and 1s. You got 3 2s and 2 1s, so that's the order that they're in. You've got 3 of the 2s and 2 of the 1s. Then with here, we've got 3 1s, 3 3s, and 3 2s. So what this one is an example of is they all have the same frequency, so it just groups them together. But also, there's this line here, I think, which is if the number of appearances is equal, then the number whose value appears sooner in the input should appear sooner. So basically it's saying it starts with 1, so that's going to be the first out of the one that's tied, and then 3 is the next one that shows up, so that's the next one, and then 2 is the next one. So we've defined our problem now. We're getting a list of numbers, and we gotta sort them by most appearances in that list to least, with tiebreakers being decided based on which one appeared first. So if we go over to any code editor, I'm using online GDB, but you don't have to, and I'd recommend against it. We've got a simple C file. I'm gonna get rid of hello world here. So usually the first thing we do is get input. So let's start with a scanf. And the first line of input is two numbers, N and C. So I'll call them that in my thing. Int N, int C. And then we're reading in two numbers, N and C. So that'll get those. And we can rename these to be more helpful for later. So let's rename N to length. And then C, that would be max value. So let's call it max val. Now we gotta read in what?
Get up to speed.
Okay. Let's see. Okay. So now we got these two numbers in. So what should we do next? It's not a trick question, by the way. I will be asking trick questions later, but this one isn't a trick question.
Read in the numbers below.
Good job. We're gonna read in these numbers. But as you can see, we don't know, or we do know, but there's gonna be a bunch of different, the number of numbers is different every time. So for this line, we gotta use a loop. So here's a loop. And let's do the stuff that's always in loops. We've got our incrementer in here, starting at 0, going up. What's it gonna go up to out of the numbers that we have here, which are length and max val? For reading in the second line of numbers.
Length.
Yeah, good job. So since we're starting at 0, as is normally the case, we're doing a less than length here. So if it's 3, it'll be 0, 1, 2. If it's 4, it's 0, 1, 2, 3, etc., etc. Then inside here, we're going to need another scanf with just %d, and then something here. And so usually what we do when we've got a bunch of different numbers is we do an array. And let's talk about some array things. In C, or I should go back to this. And then, so in C, when you're making an array, you go like this, and I think with C you have to put a number in here, and you can't use a variable. That might have changed with some compiler version of C. I think it did, but we're going to go with the rule that this has to be a constant number and not a variable. And that's something that if you're using C or similar, you gotta work around a lot. So let's search in here for a way to get around that. And a lot of the times that's going to be found in these little parentheses here, because the bounds at which the numbers can be within really tells you a lot about what you can get away with that you probably shouldn't otherwise. And in this case, the length here, the maximum value is 1,000, which as far as computers are concerned is a very small number. So we can just do this and be done with it and not have to deal with anything else. So now that we know that, I'll bring that up here to where we're declaring all our variables. So we've got our array, and then we need to read into the array, which there are different ways to do this, but I'm going to do the easier to understand way and less easy to mess up way, which is making a temporary variable and then reading into that. And then taking the array and taking array value I and making that be temp. So now this will go through length times and put in all the input numbers. So now we're at the point where we have all the values, so we need to switch back from code to thinking about things. So we've got all this, we know where it is and how it's stored, and we need to turn it into this. So, I gotta look at my notes real quick. Okay. There are very many ways to do this. Does anyone have any ideas that they've been thinking about of how you might, of some aspect of this that you might want to do or implement into our solution? Like some thing that we think we're going to need to do, or some way that we could solve this? Okay, I'll start then. So, it's called sort. So that hints that we might need to sort things using a sorting algorithm. But not necessarily. Well, technically we will need to sort things, but we won't necessarily need to do it in the way that is taught in the classes as a sorting algorithm. But if we start with the output and work backwards, you can see that it's always just going to be a series of each number. So we could potentially, one step before the end could potentially be, we've got all of these numbers and how many times they show up, and then we just print that out. Or we could actually go through the array and sort it to turn it into this. But that second one seems really hard. So I went with the first one, where we're counting the number of times each of these show up. And only using arrays, it's kind of hard to do that in a way that makes a lot of sense and is easy to read. But I came up with a way that sacrifices being good code for being easier to understand than other ways to do this. But what we're going to do is we're going to keep track of each number. Oops, wrong tab also. We're going to keep track of each number that shows up, and then we're just going to count up each time that it does show up. So we're going to need some more arrays. So let's call this first array values, and this is going to be the actual numbers that are in the array. So actually, let's call this one numbers instead. This one's also going to be size 1000, just for, because that's the biggest it can be, because that's the biggest the other one can be. And then the second one is going to be the counts of how many times each of those numbers show up. So here is where I go over to MS Paint and try to literally illustrate my point. So if we've got 5, 7, 5, 5 as our sequence of numbers, for example, we've got that in an array. What we're doing is we're making a couple extra arrays. And then we're going to go through, start at the first one, be like, okay, this first number's a 5. There is no 5 in our array of numbers, so we're adding that in. And then we're incrementing the count for that same position in the other array. And then we go over to 7. And then we say there is no 7, so let's add it on to the end and increment that. And then, once we get to one that we have been at before, we say there is a 5, we find that 5, then we go over to this array and change this from a 1 to a 2. And then, in the end, we'll have this little thing where we say that we have 3 5s. No, yeah. I thought I said it backwards, but I didn't. 3 5s and 1 7. And then, after that, we can sort it so that it's sorted. Does anyone have any questions about that? And Nick, are you watching the questions on the thing? Okay.
Yeah, if you have any questions and you want to submit them anonymously or whatever, there's a text box underneath the slides. Feel free to post a question there. I'm watching them here, and you can still get your question answered if you don't want to raise your hand in front of the room. So,
Okay.
yeah, I'm watching those.
So, one thing that I'm going to add to this for loop here is I'm going to make sure that all the values of numbers and counts are 0, so we can tell when we've reached the end. Because otherwise, right now, it's just going to be a bunch of random garbage. So numbers I equals 0 in here, and counts I equals 0 in here. Okay. Then we move on past the for loop into the great unknown just above the return. Let's see. Into another for loop, because they are very useful, especially when you're using C and can't use a bunch of helper functions. So let's start it the same way that I start most for loops, int I equals 0, I++. This time, the function of this for loop is going to be these arrows over here. So we're going to be looping through the main array that we have, the one that's called array. So this one is going to also be I is less than length. And then what we were doing here is we were seeing what the number was at I And then we looped through numbers to see if that number was in numbers. If it was in numbers, we just incremented count at the same position. If it wasn't, we added it onto the end of numbers and then added a 1 onto the end of count. So, where's my cursor? Okay. So, this part is a bit code dense, so I'm gonna pretend we have functions that we don't actually have, and then we're gonna write those functions, which can be a pretty good way to write out code that you know what you're gonna do but don't want to lose track of what you're doing. So, let's start out with another loop, because we're going through numbers. So we can just copy this loop. All of the arrays are the same length, so we can keep this here. Oh, but we need to change the I to a J, or to something that actually makes sense, but I like J. So now for each of those, if the value of numbers at J, if that is equal to the number that we're looking at, which would be the value of the array at I, so in this case this, oops, I need to get better at tab switching, array I. If those are the same, then we know that we've found the number. And in that case, what we do is we increment the count at that same place as the number. And then we can also break out of this loop, which Tom has probably told you not to do, but is fine. This is programming competitions. We code fast, not smart. So then the other case that we have while we're going through this is if we've reached the end and we didn't find it, and that's part of what this break is for, is to make sure that once we've found it, we don't reach the other case. So since we've filled the array with zeros, we know that once we've reached a 0, that it'll be the end. And something we gotta watch out for there is this right here. No, wait. This right here. Because if one of the numbers in this sequence could be 0, that would mess a lot of things up. But luckily, every number in the array is going to be positive, so not including 0. So we can just use that as a way to find the end. So if numbers, if we've reached a 0, so if numbers j is equal to 0, then we set numbers j to be equal to our value, which is array at I. Then we set the counts at j to be equal to 1, or we could keep the plus plus here, but let's set it equal to 1. And then we break out of the loop so we don't break anything other than the loop out of. Let's see. I think this is it for that. Yeah. Don't look at this, it's spoilers. Yeah, wait. Hmm. I messed up stuff, but luckily wait, did I mess stuff up? I did the other one a bit differently than this, so I'm just gonna keep going and hope that I didn't mess anything up. So back to this scribble. We've gone through, we've incremented all this stuff. We now should have this, and this will be our numbers and our counts. And now back to here to talk about what we do next. Yeah. So we've got all these numbers and how many times they appear. So now we gotta print them out in the order that of most to least appearances. And so in this case, well, let's add a few extra numbers to this, or one extra. So we're gonna take some ideas from sorting algorithms, if you know any of those, and make them a bit simpler. So we need to find the biggest one and then print that out first, and then find the next biggest one and print that out, then keep on going down until we've printed out everything. So what we can do is we can just loop through the array, to find the biggest thing. And let's say we've implemented that, we have the biggest thing. Then, to make sure that we don't do it again, we can just set this to 0, since we won't need that information after we've already printed it out. Because printing out this is the last thing that our program is going to do. So we won't need the counts of any of the numbers. So we can just set everything we've used up to 0, and that'll make sure that the biggest one will be the next biggest one, which in this case is 7. So basically, we just need to find the biggest number in a loop. So let's write another loop. So in this case, this will be the amount of times that we are finding the biggest number. Then inside this loop, we need to actually find the biggest number and then make it so that that is no longer the biggest number. So in order to find the biggest number, we need another loop. And in this loop, what we're gonna do, well, let's see. We need to keep track of what is the biggest temporarily, and then at the end, we'll have the biggest overall. So we need a few variables here. We need our max, our current biggest number, and then we'll also need to keep track of, well, actually, I won't add that yet. I'll add that later, so it's more intuitive. Basically, we have our max. Then we're going through, well, first we got to set it to something. I like to set it to the first value in the array. You can also set it to some small number that you know will be smaller than everything else. But let's just do counts 0 here, because we're finding the biggest number in counts. So in this case, we're finding out if something is bigger than our current max, and then if it is, we're going to set it to that. So if it's bigger than max, it being the thing that we're looking at, which in this case is j of counts, if that's bigger than max, then what we got to do is set max to be counts j. Oops. So now at the end of this loop, max will be the biggest number in that array. So now at this point, we have the number, but we don't have any extra context to it. We don't know what number has that many of itself. So here's where we add in that other number I was talking about, which I usually call max ID, because that's the ID of the array where that maximum was found. And we started at 0 because that's where we're getting our initial max from, is the 0th element of counts. Well, the first, but ID 0 of counts. And then when we're in here, we set max ID to just be j, because that's where we're getting that new max. So now we've got the max. So now we need to print that out in the way that the thing says to print it out, and then set that to 0 to reset it. And I'm just now realizing I never actually did the thing I said I was going to do, where we wrote functions after writing them out, but it doesn't matter. Let's see. So we've got our max. Let's go back to Caddis to make sure we've got the printing thing right. So we take the thing that has the max number of counts, and we print that the amount of times that it shows up. So we need another loop because we're doing something multiple times. But in this case, it won't be up to length. We are printing this the amount of times that the number shows up, so it's going to be counts, the element being where our max number was found, which was max ID. So then in here we just need a printf to print out the number followed by a space, and Caddis is pretty lenient on white space, so you don't have to worry about the last thing being a space or not. We can just make sure there's a space after everything. And in this place we're going to put the number that's tied to that counts, so we do numbers of max ID. Then after we've done that, we need to clear off this so that it doesn't show up as the biggest one, and so that it keeps on going down. So that would be in the counts array at the max ID, and we're setting that to be 0. So now that shows up 0 times, so it won't be printed out at all, even if it finds it. So I think this is all of the code. So let's test and see if it's all of the code by running it and then going over to Caddis and copying one of the sample inputs. I'm going to go for this one. And then just pasting it into the input. And we can see our output here was 11, 11, 11, 33, 33, 25, 25, 77, 54. And if we go over here, we can see that that is what that should be. So we did it right, probably. If this weren't something that I had already written out beforehand and tested, I would say that there is a greater than 50% chance that we got something wrong. But now I put it at about 10% chance we got something wrong. So to test to see if it actually is right, we can go over to Caddis, copy all of the code, submit, switch to editor, put it over in C++, or not C++, C, but C++ would still work. Make sure that's all there, click submit, and hope. It worked, yay. That's it. That's the thing. There's probably more stuff I should talk about. What am I missing that we were going to talk about?
We got one anonymous question that asked which link is best, but that's all I've got.
Depends on the weather.
Depends your taste in hair color. Yeah, I don't know. For those of you, if you're in 150 or whatever, and if you haven't yet touched arrays or loops, don't feel like you're behind or anything. And if there are parts that you missed or didn't really understand, sort of thing, don't worry. Don't make that a reason to not come back, sort of thing, because you'll learn things as they go along, and just little bits and pieces you'll kind of remember as you do learn about arrays and loops further on in class. You'll kind of remember about them, which will help when you actually do learn them. You can buy your own Dairy Queen if you wish, whoever posted that in the questions. And then, yeah, so don't let not knowing what's going on be a reason to not come, because I very much had no idea what was going on my freshman year, but just coming every day, every week, I was able to kind of have a head start on things and learn about them in class.
So speaking of not knowing what's going on, I should probably pull back the curtain a bit and say that while it seems like I had this solution easily, it took a long time.
A very long time for all of us.
A surprisingly long time to figure this out. These things can be deceptively difficult or deceptively easy. It really varies. Like, I had a bunch of this doing the entirely wrong thing for a while. Aaron was also doing it at the same time, and I'm only presenting because his got stuck on a weird issue. But yeah, I'm trying to think of what exactly we got stuck on so I can talk about that. type of thing. The main thing was figuring out how to sort it correctly, because we originally did both try to just use a sorting algorithm. But if you look over here, the thing that was really making this difficult was just this line right here, where the secondary sorting of these needing to be in the correct order if they're the same number. We eventually solved it. But yeah, basically this takes a lot of iteration, and also having a solid idea of what you're going to do, and then doing that, and then figuring out why your solution doesn't match up with what you were going to do. Because usually that's the problem, is there's either there's something in your code that doesn't do what you were trying to do, or what you were trying to do doesn't account for something in the problem. And yeah. We set up another competition just to do throughout the week if you want to, just a few problems.
Yeah, so we have a set of 5 problems that are all easier than this sort one. They all have like 3 of them have like a difficulty like 1.
Some of them are harder.
Some of them. It's like
1 or 2.
So that would be at competition.dsuprog.club, and we'll get like a button on the website. So it'll be right there. So in case you forget the link, just click on the button, because yeah, buttons are nice. But yeah, for the time being, while we get that button up and running, competition.dsuprog.club will send you to the CAS page. We will, run this competition for a week. So just like the last one, it'll be done, or it'll be finished by the end of next week. So feel free to take time throughout your week to work on those and just kind of continually build up your skills in C, or if you're an upperclassman and experienced in C, try branching out and doing a different language, whether it be Python or something else, to kind of build some broader skills. But yeah, that's kind of all that we've got. And then next week's meeting will be in East Hall 100, just like the other clubs. They'll all be moving back into East Hall 100 next week. So same time, different place.
So yeah, I think that's it.